Hi class. So this lesson is about lambda expressions. So a lambda expression is a simplified way of creating and using a function object. And we're going to see how this simpler format is going to allow us to write more concise code as we start using the standard library algorithms and several other use cases. So let's start by creating a simple lambda expression that does nothing except for print out just some text to the console. So I'll write a program. I'll start by importing or including IOStream. Here's my main function. Now, typically we would just write something like this, right? Hello world, and print something directly to the console. Okay. And then if we were to write a function object, sorry, this is a semicolon. If we were, and I can actually compile this and run this. And when I run the code, it prints out hello world. All right. So that's great. Now, we've learned about functions. So I could write a function. We'll call it print hello. Doesn't take any parameters, doesn't need to return anything. And this function is going to also just print out hello world. Okay, and I can access this behavior by simply invoking the function inside of main. So if I compile this code now and run it, again, I get the same output as before. And then we had learned about function objects briefly, so I'm going to convert this function into a function object. So let's create a class called hello printer, and it's going to just have a operator overload for the function call operator. If you remember how function objects work, they're basically just classes that have this special function, this special operator overload defined so that we can invoke them as if they were a function. So let's start by overloading that function. So it's called operator function, okay? And then we'll just have the body of this function print out hello function object. And I believe that's all we need to do. Let me get rid of the print hello function. We don't need that anymore. So instead of calling some function, I can create an object of type hello printer. Okay. In fact, let me just do it like this. Hello printer. Okay. Creating an object of that type. And then I can invoke that object, printer, using the parentheses as if it were a function. That's what makes it a function object. And if I compile this code and run it, we will see that I should end up printing out hello function object. So here we go, and I print out hello function object. So I've created the function object and I've invoked the function on that object. Now, a lambda expression is just a sort of an abbreviated syntax for doing this. When I create a lambda expression, I'm creating a function object. I can give it a name, just like any other variable can have a name. And so this is what it would look like. Instead of doing this with a class, I will just say auto printer. I'll write hello lambda to the console. Okay. And I can leave this line in printer. So I'm going to invoke the function. Let me get rid of this as well. So here's the same code with a lambda expression. Okay, let me run it and make sure that it works first. There we go. So I've printed hello lambda to the console. All right, so what do we have going on here? So this is a lambda expression. You know it's a lambda expression when you see these three pieces together. There's a pair of square brackets. This is for the capture group, which we'll discuss in a minute. Okay. There's a pair of parentheses, which is for the parameter list for the function. Okay, a function object has a function overload that you can invoke, which is what we're doing down here. We're invoking the function on that object. And that function can take parameters. So here's where you would specify what they are. And then the third piece is the curly braces inside of which you specify the body of the function, just like any other function. It has a body, and inside of it you can put arbitrary code that needs to execute when it's called. Okay, so we're creating a function object. It's called printer. All right. Notice the data type of this object. Essentially, we can treat it as if it were a function called printer that we can invoke, right? It returns void, so it doesn't return anything. So the return type is void, has no parameters. And so on this line of code, when I invoke the function, it's going to call that function object's function, enter the body of the function, and print out hello lambda, which is exactly what we saw going on down here. Okay, so now that we have a basic lambda or a lambda expression in place, let's go ahead and make it a little more complicated. And we're going to kind of follow the example we did in an earlier lesson with the function objects. Okay, so let's go ahead now and make this lambda expression be a function that takes a parameter. So I'm going to change the name of this to value doubler. Okay, this is the value doubler. This is going to be a function that doubles the value of some number. It's going to take that number as a parameter. So I'm just going to take int value as a parameter. And I'm also going to return something now. So I'm going to return value times 2. So this will return twice the value that was passed in as a parameter. Okay. So now when I invoke the function, obviously there's an error right here. Okay, first of all, I have to get the right name. So it's called value doubler. Okay, but there's still an error because this is a function that is supposed to, as you can see from the error message, take of integer as a parameter and return an integer. Okay, and I'm just invoking it with nothing. So let's go ahead and pass in 3. Okay, and let's also capture the result, which is just an integer, by the way, right? So invoking this function will return an integer. So the type of result is int. Okay, so if I invoke this value doubler function object, pass 3 as a parameter, I should get 6 back as a result. Okay, so let's just go ahead and print that out. Actually, let's do it like this. 3 doubled is result. Okay, let's compile our code and run it. And there we go, 3 doubled is 6. So that seems to be working just fine. Now let's extend this a little bit more and start using the capture group. So if you remember with the function object, one of the main reasons we wanted to use function objects is so that we can do some sort of initialization that will customize the behavior of the object. Maybe it has some private data members that need to be initialized, and then we can use those as part of the function execution. And so we made this sort of generic function or value multiplier where we could instantiate it with a different factor, either 2 or 3 or any sort of factor, and then that would be the number it multiplies by when you invoke the function. So this one is just hard-coded to multiply the value by 2. But what if we want to instead invoke the function and multiply by some factor? And we want to initialize this function object with that factor. Well, when you're using a Lambda expression, you use the capture group to perform those initializations. So essentially right here, I'm saying, okay, here is a private data member, basically for this function object. The name of that data member is called factor, and its initial value is 2. So this doesn't change anything. This is still a value doubler. The factor is 2. I've slightly changed the implementation, but the result should be the same. So if I compile and run this code now, I should get the same exact result as I did before. And there we go, 3 doubled is 6. Okay, great. Now, the cool thing about this, though, is I could create another one. So let me copy this and paste it. Let's create a value tripler. Okay, and let's just initialize or capture the value of 3 as the factor. So if instead of using the value doubler, I use the value tripler instead. Okay, this is the function object which captures the factor of 3. Okay, if I just use that one instead, compile and run, I guess I need to change the text as well. So 3 tripled. Okay, so 3 tripled is 9. 3 times 3 is 9, right? So the value passed in is 3 and the factor is also 3. So when I invoke this function, that value of 3 is getting multiplied by 3, and the result 9 is being returned. The reason they're called capture groups is because more often they're used to capture objects or variables from the local scope in which the Lambda expression is defined. So the scope of this Lambda expression is our main function, right? So the code in between this pair of curly braces right here. So instead of defining the factor as part of the capture group like this, I could actually have it be some variable that exists in my program already. So I could have factor equals 2, okay. And so instead of making this assignment right here, I can just capture the value of factor, okay, when I create my value doubler. And then later on, so suppose I use this code and I'm printing it out. In fact, I'm going to change the name as well. I'm going to call this value multiplier now, the more generic name. Okay, I'm going to multiply 3 by the factor of 2. And then I'm going to create another value multiplier 2, or maybe I should call this another value multiplier. And what I'm going to do is just change factor to be 3. So factor was initially 2, and then I'm changing it to 3, and I'm still just going to capture factor like this. And then I'll use another value multiplier. I already have results, so I'll just reassign it and run this code. Okay, 3 tripled is so I didn't change the text, so I should probably say 3 doubled. 3 doubled is 6, and then 3 tripled is 9. There we go. 3 doubled is 6, and 3 tripled is 9. Okay, so I'm capturing a local value, and it's important to realize that this is, we talk about value semantics and reference semantics. This is, again, value semantics, which is the default in C++ at work. So I'm capturing the value of 2, and I'm calling it factor inside of the Lambda expression. Okay, and even though I changed the local value, the local value of my variable factor to 3, when I create this other Lambda expression, I'm again capturing by value, so copying the 3 into this Lambda expression. So all of this capturing by value is great, but it's not exactly concise or clear. I mean, I would argue that this code is pretty confusing, and I have some code duplication here. I have 2 Lambda expressions that have the exact same implementation, but with different names because they're capturing at different points in time a different factor. So the real value of the capture group of a Lambda expression is that you can actually get reference semantics, okay? And so instead of capturing by value and having to create another one when I change the value of factor, I can actually capture that factor by reference. So what I do is I just say reference to factor right here like this. So value multiplier is now a Lambda expression which references the local variable called factor. Okay, so when I invoke the function, when I invoke the Lambda expression, it's going to use that factor in its implementation. So I don't actually have to define another Lambda expression here. I'm just going to use the same one now. So there's just one Lambda expression that's being defined. Okay. The result is value multiplier taking 3 as a parameter. So remember, the factor is 2, which means that when I invoke this function, it'll double the value. 3 times 2 is 6. But then the cool part is that I can change the local value of factor to 3 and change nothing else about this Lambda expression. It's still the exact same Lambda expression. And because it's capturing now by reference, when it's invoked and this operation or the body of this function runs, factor will now use the value 3 because it's a reference to this local variable which has a value of 3. So I'm able to vary the behavior of this Lambda expression, which is a function essentially, by changing the local state. Okay, so let me run the code just to make sure we can see that it's working. And there we go. So I do get the same output as before. 3 doubled is 6 and 3 tripled is 9. But again, the interesting part about this is that I've only used one Lambda expression. It's a value multiplier. It takes a value, it returns that value multiplied by some factor, and the factor is a reference to a local variable inside of my main function. Okay, now just for aesthetic purposes, I'm just going to clean this up a little bit. So I'm going to inline this part of the code. So I'm just going to print out instead of using a result variable. I think this will just make things a little bit more concise and clear for now. Okay, so you can see that I'm only this code will have the exact same result, by the way. So if I run it, I'll get the same result as I did before. And the reason I wanted to look at it like this is because now it's very obvious. There we go, the same result. It's very obvious that this lambda expression is only created at one point in time up here. Okay. And I'm just, printing out 3 doubled is and then invoking the function. And then all I'm doing is changing factor to be 3. And then suddenly this value multiplier triples values instead of doubling them. And if I wanted to quadruple values, all I need to do is set factor to now equal 4. Okay. And then I can say it'll be quadrupled. And that's it. I can just invoke the same exact lambda expression, pass in the same parameter 3, and it will now quadruple that value and give a result of 12. And there we go. Okay, so now let's look at a much more complicated example. I guess maybe a little more complicated example. So now I'm going to show you that you can use a lambda expression as a parameter to another function. So I'm creating this function called greetPerson multiple times. Okay. It takes 3 parameters. The first is a string called name, which is the name of the person. The second is a integer representing the number of times to greet that person. And then the third is a function which takes a string as a parameter and returns a string, and basically will construct the message to be used to greet the individual. So if you look at the implementation of this function, we're going to iterate the number of times, right? So the number of times that was passed in, and we're going to call the greeter function, so the greeter function being the third parameter, to the greetPerson multiple times function. So functions can be parameters to other functions, okay? So we're going to invoke that greeter function, and we're going to pass name, and the greeter itself, which is a function, is going to take the name and construct a greeting from that name and return that and print that to the output stream. So now let's look at where it's being used. So here inside of main, we're calling greetPerson multiple times, initially with Anna. So the name of the person to greet is Anna. We're going to greet her 2 times, and we're going to use the casual greeter function to greet her. And you'll notice that the casual greeter, the formal greeter, and the slang greeter, these are my 3 greeter functions. These are defined as lambda expressions here inside of main. Okay. So the second time we call the function greetPerson multiple times, we're going to call it with William. We're going to greet him 3 times with the formal greeter. And then finally, we're going to call it using Jenna as the name 4 times using the slang greeter. So each greeter is going to take a string and return a string, and it's going to use that string to construct the greeting message. So let's go ahead and run this code. And there we go. So there's the output of running this code. You can see if we kind of follow it through main, we're going to greet Anna twice casually, and there we go. Hey Anna, hey Anna. And then we're going to greet William 3 times formally, and you can see the 3 good morning William statements being printed to the console. And then finally greet Jenna 4 times with slang, and then we see yo Jay what up printed 4 times. Okay. All right, so it's working, it's printing, it's calling this function and printing out the names and the greeting the proper number of times. Notice that the function, which is a parameter to the other function, so the greeter function is a parameter to the greetPerson multiple times function. These are just functions, okay, but we're defining them as lambda expressions. So we're able to define them in the local scope, okay. Now again, you might be thinking, well, why don't I just, define an actual function? So I could have a function that returns a string called casual greeter. Okay, it takes a string called name, and it returns hey, and then the name of the individual. And I'll of course, I'll have to do this string literals thing each time I want to use the string literals, but that's okay. So I could define the casual greeter like this, so that instead of using the lambda expression, I actually use the function. All right. And if I were to compile this code and run it, it would work just fine. So in many cases, lambda expressions are just equivalent to, let me run it again and you can see the same output, right? So lambda expressions are equivalent to just defining a free function in your source code. So why would you want to use lambda expressions then? And so now let me try to show you why it's actually useful to use a lambda expression instead of just a regular free function. The thing about lambda expressions is we've been creating them and giving them names as if they were variables, and then passing them like this, but actually lambda expressions, they are expressions and they can just be defined in place. So instead of creating one called casual greeter and then another one called formal greeter, uh, I can actually just define them in place when I'm actually trying to or needing to use them. So let me just get rid of these completely. Okay. And you'll notice now inside of the body of the main function, I'm going to call this greet person multiple times function. I'm doing this 3 times. And each time I'm providing a different name, a different number of times, and a different lambda expression just right there in place in the parameter list of the function invocation. Okay. And again, I will have the same exact output as before. Let's go ahead and double check that. There we go. Same output as I've always been getting. So lambda expressions are really useful when you just need like a one-off function, something that you're just going to use once. It's nice to define a function out here inside of the in the source code that can be used multiple times. But if I need some sort of functionality and it's only used in this one place in my entire program, it's nice to be able to actually just define that in place. And lambda expressions allow us to do that. So what are the main benefits of using lambda expressions? They're basically functions, but they're actually function objects, so they have all the power of a function object, and also they can be given names, and also they can be defined in place right where we need them.